let's have a quick discussion on hydrides of 15th group elements so that you can easily solve this kind of questions, right? Okay, so what are the hydrides? We have BiH₃, NH3, AsH₃, SbH₃, BiH₃ are the hydrides of these 15th group elements, right? So now what are the properties it has? The first one is thermal property or thermal stability. So what exactly it is? The stability order of these hydrides we need to give, right? So now what happens is down the group thermal stability decreases. So thermal stability down the group decreases. So why it is decreases? See here, this size of central atom is increases down the group, right? So down the group for 15th group elements, what happens as we go down the group? Size increases. So therefore the size, the difference between the size of hydrogen and the central atoms will be varying very much, right? Therefore the overlapping between bismuth and the hydrogen is very weak in the last case, right? Here in this case. Therefore the bond between bismuth and hydrogen is very weak, so easy to dissociate, right? So that is the reason the thermal stability down the group decreases. So I also told you bond dissociation energy also decreases down the group because the BiH bond is very weak, easily dissociates. So bond dissociation energy also decreases. Now what happens to bond angle? So bond angle also decreases down the group, okay? And what about basicity? Basicity down the group, it is also decreases, okay? So why these two reasons, or what is the reason behind these two things? See, here we can say in this molecule we can generally consider them as no hybridization from here to here, okay? So we are calling them as Dragos compounds. So what actually the bond order for this? So there is no hybridization between them. The bond between phosphorus and hydrogen is considered to be having more p character. So for all of this having more p character. So down the group the p character between bismuth and hydrogen, the central atom and the hydrogen is increases, the p character increases, and the lone pair electrons here which are present on all of these elements will be lies in the s orbital, okay? So the lone pair electrons here will be lie on the s orbital with more s character. It means they are very strongly binded to the central atom. Therefore it is difficult to donate these electrons to the other electron deficient, that is H plus or proton, right? So therefore its basic nature is very less. So down the group what happens to the basic nature? Decreases. And what about the angle? So down the group bond angle also decreases. For this we have almost near to 107 degrees, and all of this having in and around 90 degrees. This is for 93 like that, I will show you, okay? So I hope it is also clear. Now reducing nature, what happens to reducing nature? Down the group reducing nature increases. Why it is increases? The bond between B and H is weaker, easily dissociate, and hydride ion shift, donation of hydride ion easily takes place. So reducing nature increases as well as acidic nature also increases, okay? So these are the things you have to remember from here.